Hey guys, this is Harshita, and today I would like to share with you guys a chemistry tip from the Belmont Math Science Center. My tip for today is going to be about how to draw Lewis structures. Lewis structures are actually quite fun to draw once you get the hang of it and know how to do them correctly. So today I'm going to give you a quick overview of how to do it. So let's start with carbon dioxide, CO2. The first thing that you want to do is write down the number of electrons that are there in the highest shell of each of these. So carbon has 4 in its highest shell, and oxygen has 6. So it's 2 times 6 because there's 2 oxygens. And so that is 6 times 2 is 12, plus 4 is 16. And the next thing you want to do is find which of these is the central atom. The central atom is going to be the one that is least electronegative. So if you look at your periodic table, and you look at the periodic and electronegativity trends, electronegativity is highest right about here. Fluorine is the highest, or fluorine is the element that is the most electronegative. So when you're looking at C and O, C is more to the left, so it's less electronegative. So that's the central atom. So I'm gonna draw a C right there. Just for the sake of it, I'm gonna put an O. And I'm going to fill this up with electrons. And the goal is, if you add all these electrons up, it should equal to this number that we calculated over here. So if I count them up, it's 2, 4, 6, 8, 10, 12, 14, 16, 18. That's too many. So I'm going to take one of these and one of these away. And I'll take that one away too, because carbon can't have more than 4 bonds. So if you count this up now, it's 2, 4, 6, 8, 10, 12, 14, 16. And it works. So that's carbon dioxide. Now if you move on to phosphate, phosphate has a combination of phosphorus and 4 oxygens, and also has a total charge. So if we do the same thing that we did over here, we're gonna add up all of the electrons that are in the highest valence shell. So phosphorus has 5, and oxygen has 6, and I put 4 because there's 4 oxygens, and we see that there's 3 electrons more, or 3 more electrons. So that's plus 3. So that would be 5 plus 6 times 4 is 24 plus 3. So that is 24 plus 5 is 29, plus 3 is 32. So the total number of electrons in the structure should be 32. And now we need to find the least electronegative atom to find the central atom. So we're looking at P and O, and P is kind of lower in the next row, so that is less electronegative than O. So P is the central atom. So let's go back over here. Let's draw this over here. Yes. And I'm still going to put out 4 bonds. And I'm going to put out all the atoms. Or electrons, sorry. Okay, so now we need to count them up, and we need to make sure they equal 32. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So it looks like this one works out well. So now we look at the formal charge of each of these, because we need to make sure that the 3- is satisfied as well. So formal charge is found by how much it's supposed to have. Minus how much it actually has. So if we're looking at this oxygen is supposed to have 6 electrons. So we count up 6. But then it actually has 2, 4, 6, and 1 from the bond over here. So it has 7. So that means it has a -1 charge. So it's negative. And all of these oxygens are similar to this one. So all of these have a negative charge as well. And then you look at phosphorus. Phosphorus likes to have 5. So it's 5 minus, it has 1, 2, 3, 4 for 1 from each bond. So that is a +1 charge. So that is a plus. So one of these plus and minuses get canceled out. So we have 3 extra negative charges, which is where this 3 minus comes from. So that's the Lewis structure for a phosphate ion. I hope this was helpful. If you have more questions, please contact your professor, or please visit us at the Belmont Math Science Center on the first floor, Jack. Thank you.